So chapter 5.2 gives us these graphs and asks us to determine what the highest power that these functions could possibly be. So we start off by covering the general polynomial form. Okay, so if we have some function p of x and we have a constant a of n times x to the n, so n is going to be the highest power because it's in descending order. Then we have the next term, a to the next term times x to the next power. All the way we keep adding until we get to, let's say, a sub 2x squared, and then a sub 1 x to the 1, and then a sub 0 x to the 0. So in this case, a of n, or all these a's, are some coefficient that correspond to the x to the nth power, with n being the highest degree, or the degree of the function, the highest power. So we start with x to the n, the highest power, and we keep adding them in descending order until we get all the way to, let's say, a sub 2x squared, or then a sub 1 x to the 1, which is just x, and then this a sub 0 x to the 0 is just our constant at the end. So for our polynomial functions, if we are given t turning points, and turning points are defined as the points in the graph where it goes from increasing to decreasing or decreasing to increasing. So points in the graph where the graph changes its direction. So if we have t turning points, then our equation is going to be, or our highest power is going to be n equals t plus 1. And what that means is if we have 4 turning points, for example, then our equation must be at least a 5th degree polynomial. So we can look at this. So we can look at examples of this with the graphs given to us. Let's call the first one f of x. So the first thing we want to do is count the turning points. We have one right here, another one right here, another one here, and another one here. So in this case, for f of x, t equals 4. Then that means n must be 5. So f of x is at least a 5th degree polynomial. Let's call the second one g of x. G of x has 2 turning points, so t equals 2, then n must be 3. G of x is at least a cubic function. And that means that the power could be actually higher. It could be a 4th or a 5th or a 6th or even a 10th degree. But it has to be at least a cubic function because we have 2 turning points. And then for h of x, we have 1 turning point. So if t equals 1, then n equals 2. So h of x is at least a quadratic function. And then let's call the last one k of x. And for k of x, there are no turning points. So t equals 0. Then that means n must be 1. So k of x is at least a linear function with the power of 1.